Hello, welcome to this week's Pat Problems with Helena and Kat. This week I'm going to be taking you through the solution to question 7 of the 2014 Pat paper, which is a straightforward maths question asking us to sketch the region defined by these three inequalities and evaluate the area defined by them. I am always in favour of a well-labelled diagram. But given that this question is specifically not just asking us to evaluate the region, but also asking us to sketch it, in this case, that sketch is particularly important. So let's get some values in there. I'm going to match them, and I'm going to focus on this central area between -4 and 4 in both directions, because this is where I'm interested in, as you will very shortly see. To sketch these three inequalities, I'm going to start at the beginning with y equals x squared. I'm going to ensure that I come through a couple of these key points to make sure that the sketch that I end up with does indeed land through the correct points and give us that lovely parabolic shape of y equals x squared. My second inequality is defined by y equals 0, which I already have in place because I've got that axis, but I need to add the upper bound of it at y equals 4, which I've done now. Leaves last but not least, y is greater than or equal to 2x minus 4, so I'm coming through the y-axis at -4 at a gradient of 2. And intersecting with my two of my bounds, but not with my parabolic curve. So I've got my three bounds drawn. To evaluate the area defined by them, let's start by shading that region in. So there's my region defined by the inequalities. And that region divides really nicely into two sections. I'm going to call them A and B. And those are both straightforward to evaluate. To evaluate the area of region A, I'm going to be evaluating the integral between 0 and 2 of that curve x squared with respect to x, which is a very straightforward integral. It's a third of x cubed between 2 and 0, or 1/3 of 2 cubed, take 0, 8/3. Calculating the region B is similarly straightforward. B is just a triangle, meaning it has an area of 1/2 times its base, which is 2 units, times its perpendicular height, which is 4 units, giving me 4 units overall. So my region A plus B, which is the region defined by these inequalities in the positive x direction, is 8/3 plus 4, or I would go for 20/3, but I will leave that to your discretion. Probably noticed that I suddenly pointed out I was evaluating the region between the inequalities in the positive x direction. When we first sketched this in, we did not look at the negative x direction. We're going to look at that now. This gives us a third region, which rather unimaginatively we can label as C. This third region still fulfills the criteria of having y between 0 and 4, having y less than x squared, and being greater than 2x minus 4. This region is unbound as we move down through the x values, which means that the area of C is actually an infinite value. So our total area defined by the curves is also infinite, A plus B plus C. I hope that helped. We will see you next week for another Pat Problems solution. Thank you very much.